There we go. It's science. Alright, so why did it work? Why were you able to take that little vial of cold water and place it in the hot red water and it heated up? Because the water didn't actually touch the water, did it? Okay? The water did not touch the other water. There's like a, I don't know if it was glass, it's probably a plastic container there. That vial was a barrier. It was separating the cold water on the inside from the hot red water on the outside. So why did it work? Jenna?
Because there was hot water all around it, so it heated it up. Because I got the plastic hot and I got the cold water hot.
Say that a little louder. I like how you explained it.
It was surrounding the cold water, and then the hot water would get the vial plastic thing hot, and then that plastic would get the cold water hot.
So it's like the cheese touch.
What?
Right?
You know what that is?
The cheese touch? Like if I've got the cheese touch and I give her the cheese touch, now she's got it, but she touches Trey, Trey's got the cheese touch now, right? That's basically what's happening with heat. Right? There's hot water. It now touches that vial, that plastic vial. Now the plastic vial is hot. That plastic vial touches the cool water on the inside. Now it becomes hot too. Right? And we're going to talk a little bit more in depth about how that actually works. Two things that I wanted you to take from this. First of all, heat, and then the transfer of heat like we saw, is related to particle motion. So we're going to talk about what's inside what makes up the water at a very, 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 very like microscopic level. And then heat transfer happens by conduction. Did we use that word last time?
No.
Okay. Conduction, which is where two things really just touch. We talked about it with our feet on hot sand or on a hot sidewalk in the middle of the summer. And I said, well, the sidewalk is hot, but why does your heat get warm when you step on it? Because there's contact, because there's touch, right? So those two things are true, and we'll come back and review that. If I put an ice cube in my hand, I don't have one in here now. But let's say I put an ice cube in my hand. What am I going to feel, Braylon? Stand up. Do two jumping jacks. I'll come back to you. Mac, what do I feel?
The coldness from the ice cube.
The coldness from the ice cube is what most people would say. That's technically incorrect. It does feel cold in my hand, right? But what's really happening here? It's not that the ice cube is transferring cold to my hand. It's actually just the opposite. I said two, man. Do you know how it counts? He's back there like, how long do I need to do these jumping jacks? What's actually happening? Luke?
It's the ice cube getting warmer.
Yeah, it's the warmth from the heat from my hand goes to the ice cube. And because there's heat leaving my hand, I feel, we call it cold, but it's really a lack of heat. What happens to the ice cube then? Because it's sitting in my hand. It might take a couple seconds, a couple minutes. Claire?
It melts.
Yeah, it's going to melt. Okay, why? Because there's a bunch of heat that just got transferred to it. Okay, so heat transfers from your hand, which has more energy. If you've got more heat, you've got more energy. And because that heat transfers to the ice cube, now the ice cube has more energy than it did before, and it starts to melt. Your hand feels cold. Okay, so the same thing was kind of happening here in our past experiment. I'm going to show you, if I could zoom in on parts of the water and zoom in some more and zoom in some more and zoom in some more. Water is made up of tiny little things. We call them particles. So each one of these little circles represents particles. And there's a whole bunch of these different particles that make up all of that water. Let me go to... Okay. So here's what those particles look like in the liquid stage, in water. Okay, they're touching and they're kind of like rotating over each other. If I froze that water, if I made it solid water, here's what those particles look like. There's still some movement, but not much. And they're more kind of like this, where those particles are now vibrating next to each other. Okay, but if you think about a wall, Mrs. Pratt's like, what's going on? If you think about a wall or a chair or a desk or anything that's a solid material, those are all made of particles, but those particles are basically just vibrating. Anything that's liquid, like water or soap or something like that, has particles, same particles, but now they're moving in a different way. Can you guess what, if we turned it into a gas? In this case, water vapor, right, which is like water in the air. Yeah, they're like completely broken apart and they're flying all over the place. Okay? So now, let me go back to water. This is water at 20 degrees Celsius, which is about room temperature. I might be a little off on that. Here's what happens when we warm up that water. Does it look the same?
No.
What's different about it? They're similar. They're still kind of, their movement is still kind of rotating over each other. But what's different, David?
They're like,
Mac, you think you got it? Well, yeah, there's not actually more. I think it's just the picture. Caleb?
They're moving faster.
They're moving faster. So when you start heating something up, at one point they're moving over each other. You start getting hotter, and now they're moving around each other, kind of like that. Okay, and pretty soon, if we warm it up fast enough, and the water would start boiling, now it would become gas, right? It would become water vapor and start looking something like that. And you warm up that, and now it's really flying fast. Luke.
it'd be fun to be one of those guys. Well, it'd be a ball.
Okay, so let's take a look at this. Here's solid water, in other words, ice, and we could start warming up. Oh, maybe it's not going to let me grab that. Can I grab this or not? Maybe I need to actually just go to phase, show phase change. I thought it let me slide. There we go. Okay, so ice, they're just barely moving and vibrating. You start warming them up, it becomes liquid, so they're kind of rolling over each other. You take that liquid, now it's getting really hot, it's starting to boil, and now it becomes water vapor. Does that make sense? So if you think about all of these, and all of those things, they're really colliding, right? So when you've got these two different substances, for example, the cold water in the vial, and the vial, the plastic vial itself, what's really happening is those particles are hitting each other. They're colliding. We call that conduction. And because of that conduction, some of the energy transferred from the cold water to the vial. And the vial that's like this, right? It's a solid. It starts vibrating a little bit more because it's got more energy. Now it transfers some of that to the cold water. Now,
Are particles a solid, liquid, or gas?
particles themselves would not be considered any of those things. Particles are what make up a solid or make up a liquid or a gas substance. Caleb.
What does the warmed up solid water look like?
Warmed up solid. So it's going to be where they're stuck together and just vibrating, but they'll vibrate a little bit more quickly.
Yeah, there's a button for it. It says show warmed up.
So warmed up solid water.
And just waste a little bit of
A
time.
little bit. Yeah. Luke.
So, what are particles? Like, would we just call them particles?
Yeah, we haven't gotten into that, but really all these particles are made up of elements. So the periodic table,
Then where do
particles are made up of certain elements on that periodic table. So we've gotten smaller and smaller and smaller, but haven't gotten there yet.
molecules come into play? And
that gets even smaller. Don't worry about that for now. When you get, that's really part of that is what we've been going through in our 7th and 8th grade chemical interactions class, so you'll be getting to that stuff eventually. For now, we're taking a little bit more basic approach. Okay? So with that in mind, we went from hot water particles on the outside, that was like the outermost cup, and we eventually got to the point where we said, we can see the temperature rise. How can we, and it wasn't just the cold water whose temperature rose, but something actually happened. The little red liquid inside the thermometer moved. So how did we get from here to here? Well, hot water particles transferred some of their heat to what? Stand up if you know. The hot water particles transferred their heat. If you want to draw what we just did, you could draw what we just did, right? We had a cup like this, and we had, inside that cup we had a vial, and inside that vial we had the thermometer, right? Okay, so the hot water particles transferred their heat to, Jenna?
Cold water?
I don't think so. Not immediately. What did the hot water hit and collide with first? We call that conduction. And transfers energy because it hit something.
The competitor?
No. I mean, technically it did, right? Which is why eventually you could feel the heat holding that cup. I just thought as we're getting closer to the inside, though. Sam?
The vial thing?
Yeah. They actually touched the plastic particles of the vial. Okay, so hot water had a bunch of energy. It transfers some of that energy to the plastic vial. Now that plastic vial has more energy. It's shaking a little bit. It transfers some of its energy to what?
The cold water.
The cold water that's inside the water, or inside the vial. And now some of that cold water transfers, which is now warmer and has more energy, transfers its energy to
The thermometer.
the thermometer, the glass of the thermometer. The glass particles of the thermometer are touching the liquid, the red liquid inside the thermometer, and that's what causes it to have more energy. And when it does, it expands, which is why it kind of goes up the thermometer. Does that make sense?
Yeah.
So again, it's like it's like the cheese touch. That hits that. That's got more energy. Now it gives some of its energy to the next one. It gets energy to the next one. Yeah.
So how long does it take? Does it just like right when it hits the hot water, does it just...
Ooh, that's a good question. How long does it take? Some things take longer than other things. We're going to be taking a look at that a little bit tomorrow. For example, if I would turn on a blow dryer and I would shoot that blow dryer of hot air against the wall here, if this whole cheese touch concept works, this conduction concept works, shouldn't that blow dryer make the air hot? That air makes the wall hot. The wall makes the air in the other room hot, and therefore Mrs. Pratt and all the preschoolers are now all warmed up. Right? Technically, that's how this is working, but some things conduct heat a whole lot better. Okay, and some things are barriers to that kind of transfer of energy happening. Okay, some things work really well. For example, if you have a hot, well, we'll talk about that later. Yep.
What if the thermometer's crossing its fingers?
Not sure. I'm not sure about that one. All right. Let me talk to you a little bit. Let's write this down. In your, let's do it on your science notebook, because then you can probably transfer some of these key ideas later to your website. Okay, here's the first main concept I wanted you to take from that experiment. Heat, the idea of heat, is related to what? Thinking back to this. Heat is related to, what do you think? Margaret? Particle motion. If you heat something up, the motion of those particles is going to increase, right? They're going to be moving faster. So that's one major concept. The other concept when talking about heat heat transfer in conduction, right? That's one of our big words. Heat transfer in conduction happens when what? What is conduction? How does the cheese touch of heat transfer happen? David? What you say two things. What's a better word than things? Particles, yeah. Happens when particles collide. Okay? Those are the major things that I want you to take from that last experiment. The idea of heat is related to particle motion, and we can transfer heat through what we now call conduction when particles collide. Luke.
What happens when particle is split?
Again, we're going to save that for a little bit later. Because some particles, for example, like water, has particles that we call H2O,
Yeah.
right? Which is two hydrogen atoms and an oxygen atom. Chemical reactions cause them to split differently too, but that's for a more in-depth study of all this stuff. Sam?
Based on your example, does that mean that I can cool down if I cross my fingers?
Explain why you would say that.
Because you said it's like the cheese touch.
So what does crossing your fingers have to do with that? Is it, holy cow, it is that time already. Man, I thought I had a good 15 minutes left. Well, we got those two major things written so far. We're going to finish this up first thing tomorrow, and then we're going to take some of this information and put it onto our webpage as well. So that's all we'll do for now.